So right here, guys, remind me how to turn degrees into radians from yesterday. What was the rule?
Pi over 180.
So we're going to take any degree times pi over 180. Okay, so I don't believe we did this example right here. So we would take negative 105 times what here, guys?
Pi over
Times pi over
180.
180. Yep. Okay, and this would become negative 105 pi over 180. Okay. Want me to help you simplify that? The negative 105 over 180? You want me to do that for you? Do you guys have simplification tools in your calculators to make fractions simplest, in the simplest form? Some way, somehow? Okay, I'm not going to freak out if you do or don't, but I see both of these ending in 5. Anybody know how many times 5 will go into 105? 21, and it'll go in here 36 times. I know that 21 and 36 are both divisible by 3. What's 21 divide 3? 7. What's 36 divide 3? Okay, so this actually is going to reduce to, and again, you'll get there. I know I'm going quickly through this. Again, what am I worried about? Process. You understand the process with me right now, I hope.
Yeah.
Okay, this simplifies to negative 7 pi over 12 radians. Okay. All right, and then likewise, yesterday we said, how do you turn radians to degrees? If degrees to radians meant times pi over 180, then what was the opposite of that? Times 180 over pi. So in this example right here, we want to turn 14 over pi divide 5 radians into degrees. So the rule for this is to times this by 180 over pi. All right, you guys help me with this. Okay, times by 180 over pi.
Pi's cancel.
The pi's cancel. Okay, so I see this here as just basically really 14 times 180 divide 5, right? I'll try and beat you. 36, 360, 72, 144, 504.
Yeah.
Did I win? Is it right?
Yeah.
Oh, good. Yeah, you would go 14 times 180 divide 5. And don't ask me why I know that. That's just weird. But it's kind of geeky too, and I like that. 504 degrees. Okay, 504 degrees. By the way, is that more than one revolution then?
Yeah.
Okay, that's a revolution and change, right? Okay. The Americans love to have a revolution a long time ago. Let's talk about revolutions here. Woo, that was... We talked about the American Revolution in Sharknado 6. Anybody watch Sharknado 6 the other night?
Did not.
Am I the only one? Tell Legends of Sharknado.
I've never seen it. I watched it.
Has anybody ever heard of the Sharknado?
I haven't seen it.
You want to know what's really bad? I have a t-shirt that has a little tornado with sharks in it. It's good stuff. I should wear that someday, shouldn't I?
Casual
Okay.
Friday.
What's that?
Casual Friday.
Casual Friday. All right, hey, general rule here, kids. I think I might want to have you highlight this. This is good stuff right here. General rule. It says, unless we are converting, when you are given radians, what? Okay, the thing about trig as we move through here, they're going to talk a lot about degrees and they're going to talk a lot about radians. General rule for trigonometry says if you're talking about angle measures, typically they're talking in radians unless they tell you to put it in degrees, okay? So things I want you to get used to this year. They say, what's the measure of that angle? We're not thinking degrees so much all the time as much as we're going to talk about radians, okay? So radians and degrees, they go together, all right? How many radians in a whole revolution? You remember that from yesterday?
2 pi.
2 pi, because the formula for circumference is 2 times pi times r, where r is like the number of radians, okay? There's 2 pi radians in a full revolution, all right? Things to remember. Oh my gosh, that was a crazy question, because I put it right here, didn't I? 180 degrees is what?
Pi radians.
Pi radians, things to remember. And 360 degrees is equal to what? 2 pi radians. Keep that in mind. You might want to star this right here and make sure you know that this stuff's important, okay? Important stuff. All right, kids, page 2. Any questions there at all? I know we're going kind of quickly, but you understand how to go degrees to radians, radians to degrees. That's my first question. Okay? Hey, quick from yesterday. How many minutes in a degree? 60. How many seconds in a degree?
3,600.
3,600. Remember that, okay? All right, page 3. This is a pretty important page right here, okay? This is a pretty important page right here. In this right here, it says 1 radian is approximately how many degrees? 57.3 degrees. And here's how they come up with this, okay? 1 radian, okay, is approximately 57.3 degrees. Let me show you how they come up with this. 1 radian, whoops, I didn't want to do that. What I wanted to do was this. This would be like turning a radian into degrees, right? So if I take 1 radian, that would be the same as turning to degrees by taking that by 180 times, or I'm sorry, over pi. Okay? Does anybody have a calculator handy? Okay? Do this with me. I want you to take 1 times 180, should know that. 180, and then divide that by pi. You get about 57.3. So when I say, hey, I'm dealing with just 1 radian, that's approximately how many degrees? Okay, so if I take 1 radian and want to turn it to degrees, well, the rule for turning stuff to degrees is to multiply by 180 over pi. This is about 57.3 degrees. That's where they get that from. Okay? Well, not percent. Come on, Parson. Whew! Second day and I'm making mistakes already. I made 14 yesterday. You didn't even catch them. You just believe me, all 14 times this one. I'm kidding. Come on. All right. This is a really important concept, kids. 2 angles are considered, what's the word here?
Coterminal.
If they begin and end at the same place. Okay, so as an example right here. Okay. We talked yesterday, angles that are going to have an initial side and a terminal side. And I'm going to talk specifically first about this angle right here. So you might want to highlight this. I'm going to highlight this angle right here. Oh, let's pick a pretty color today. How about this one? I'm going to talk specifically about this angle right here. Okay? My initial side is always on the positive side of the x-axis. Basically, it's to the right here. Okay, that's where this is always going to start. All right? And then this is considered my terminal side right here. How many degrees is this, kids? 60 degrees. Now, when we talk about angles, when they are generated from circular motions in a coordinate plane, we always start over here on the x-axis, and you always are moving, typically when you count angles, in a counterclockwise direction. So moving from here to here, how many degrees is this right here? 60 degrees. Now what direction did I move from the initial side to the terminal side? Counterclockwise. Okay, I want to tell you this right now. Anytime on your talking angles, anytime you move in a counterclockwise direction, you're moving in a positive degree direction or positive radian direction. Okay? So if moving counterclockwise means the number's going up, what do you think the opposite means if we start rotating clockwise? Negative numbers, right? So let me show you this quickly. Clockwise means you're moving down in a degree value. So this angle right here of 60 degrees, while it says 60 degrees, I move counterclockwise 60 degrees, no problem. Okay? Let me show you another thing right here. Is it possible that I could start here, go up to 60 degrees, go all the way around again, and be back at the same angle? Like that right there? If I go 60 degrees and then a whole other revolution to get back to that, what's 60 plus that whole revolution of 360 going to be? 420! Ha 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 ha! Okay, 420 degrees. 420 degrees would be coterminal to what? 60, okay? And then if I go another 360 degrees on top of 420, where are you at? 780, okay? Basically, to get a coterminal angle, you keep adding a whole revolution to what you had originally. Okay? When you're talking degrees, to get a coterminal angle, you always add 360 degrees. But let me show you something else. That's only if we were moving what direction? We might also want to move what other direction? If I start here to get back to this terminal side, I could work backwards how many degrees to get over here? Negative 300. Think about it. What's 60 minus 360? Okay, so to get coterminal angles, you either add or subtract what degree value, kids?
360.
But what if I didn't like this degree stuff? Because I just got done telling you, you know what? Trig's going to tell you, we want you to put stuff in what?
Radians.
Radiance. We would really like you to put stuff in radiance. This is bad, very bad. What's one whole revolution in radians? 2 pi radians. So you're either going to add or subtract 2 pi radians for this. Okay, so I'm going to write it this way, or 2 pi radians. That's a pretty big note right there for coterminal stuff. I want you to highlight this, box it in, do what you do to call attention to something that I think is important there. Okay, if you want a coterminal, here's a number, 20 degrees. Give me a coterminal angle to 20 degrees. 380. Add 360 to it, you're at 380, right? Okay. What if I did it in radians? You have pi radians. Give me a coterminal angle to pi radians. 3 pi radians. Because if you're in radians and you're at 1 pi as your angle to start with, what's 1 pi plus another full revolution of 2 pi? 3 pi. Or could I have subtracted 2 pi and gotten negative pi radians? Okay. Anytime you're looking for a coterminal angle, what are you supposed to do? 360 if you're in,
Degrees.
or
2 pi.
if you're in. Let's try this, kids. So right down here, here's an example. You know what? You guys do this for me. Give me a coterminal angle for both of those. You guys do that. I think the first one will be very simple. I think the second one might throw a curveball by you. If I hang the curveball, you hit it out of the park. All right? Don't be swinging at the one I'm trying to throw in the dirt for you. You got that, Tech? Watch the curveball. I'm going to go fill up my water. You guys talk about those two quickly. I will be right back. All right, let's chat. Anybody have a coterminal for 45 degrees? How much?
395.
395, close.
405.
Oh, 405. There you go. Ben said 405. How many went with 405? Because the easy thing to do is add how many degrees? 360 and 45, right? Okay. Did anybody subtract 360?
Yeah.
Who did? What'd you get?
Negative 350.
Negative 315. I like that. Did anybody just say, you know what? I really like circles, so I want to do it twice and go around and add 720? Or maybe you're like 3 laps, green, white, checker, finish. NASCAR fan? Maybe you wanted to add 1,080 degrees to it. I could keep going on forever, couldn't I?
Yeah.
Okay? You only have to add once, but you could keep adding 360 and then add another 360 and then add, or subtract 360. All right, so the kind of the obvious ones are either add or subtract. And I think a lot of you kids, probably added 360 to this to get 405 degrees. Whoops. I think a lot of you added to get 405 degrees. Or what did you have again, Ben?
Negative 315.
Negative 315 degrees. Very good. Okay. How about part B? Coterminal of 13 pi over 4 in radians. Anybody have an answer?
21 pi over 4.
21 pi over 4. I like it.
Oh.
Let's talk here quickly. What's the rule, first of all, for doing or finding a coterminal angle in radians first?
Adding
Add 2
Okay, so we're going to add 2 pi. Okay, going back to some elementary algebra stuff here. Or to add fractions right here, you have to have common denominator. What do you want your common denominator to be? So this should be 13 pi over 4. Plus, if I multiply to get this to be a 4 on the bottom, what's the top going to become then? 8 pi. Yep. 8 pi over 4 is still 2 pi, isn't it? Doesn't the 8 divided by 4 still get you 2? So it's still 2 pi, right? So if you're adding radians or subtracting radians, you have to make sure you have a common denominator, all right? What did you get again there, Ben?
21 pi over 4.
Excellent. 21 pi over 4 radians. Okay? What if I would have subtracted 2 pi radians? What would 13 pi minus 8 pi get you? 5 pi over 4. Okay? Are we okay with finding coterminal angles? Okay? And there'll be a huge, this will be a big, big thing as we move forward. Coterminal angles are going to be based off of initial angles that are very important, and understanding this concept as we move forward this trimester in trig, that'll be very important for you. Okay? Any questions on this page at all? All right, last page, and then I'm going to turn you loose on some things, okay, kids? Anybody need more time with this page? All right, let's rock and roll. This is an important one. Reference angles. Reference angles are always angles, the angle measured from the x-axis. Okay, so it's kind of an initial position. They have to be what?
Positive.
They have to be positive and either between 0 degrees and 90 degrees or between 0 and pi over 2 radians. Okay, this is where things get kind of interesting for us. I want you guys to open up your books, the page, I think it's like around 245 or 246. Actually, it's on page 243. My mistake here, okay? I'm going to make a reference to all this stuff right here. I'm going to make a reference page 243 in the notes of your book, okay? Do you guys see that little table down there where it says reference angle rules down there at the bottom? Very bottom in yellow there. You guys all see that? Okay, there are rules. And we'll put these rules up in the notes too. But it says the following. On page 243 at the very bottom, rules for reference angles. It says for any angle alpha, such that alpha is between 0 and 2 pi, 0 and 2 pi because that's one revolution on a unit circle, it says its reference angle, which they denote as alpha prime, is defined by, oh boy, there's 4 cases. Okay, what's the first case there? They call it A. It says alpha when terminal side is in quadrant 1. What they're saying is this. If you have an angle, I'm going to draw a picture here. Is it okay if I draw a picture over here to make this a little easier or more understandable? Okay. You guys all know that sometimes circles are put in a coordinate plane broken up into 4 quadrants. Okay. If you have, well, what's this quadrant right here, kids? What's this? What's this? Hook me up. That quadrant has a lifeline right there. IV. Ah.
Oh my goodness.
Okay, here's the deal. Read that up there again. Reference angles are always measured from what, kids?
The angle
And they have to be what?
positive.
And they're either between
0.
or what? Okay, so a reference angle is always going to fall. You guys agree that if we start an initial side at 0 degrees and 90 degrees is always up here, a reference angle will always fall on what? First quadrant. I'm going to make a note up here, okay? Reference angles, I'm going to abbreviate a little bit, always fall in quadrant 1. Reference angles are always going to fall in quadrant 1. So they give us some rules right here, and what they're saying is this. Listen to this right here. Suppose your angle falls in quadrant 1 already. Okay? If your angle is already in quadrant 1, do you need a reference angle? Absolutely not. And that's what this is saying. If you read this yellow box down here, this is saying for any angle alpha that's between 0 and 2 pi, its reference angle, which we define as alpha prime, is defined by, you see where it says part A there? It just says your angle is already known when you're already in quadrant 1. So in quadrant 1, your angle stays the same. Okay? Your angle is always going to stay the same. Now I want you to be careful on this because I'll show you some examples here, but your angle will stay the same if it falls in quadrant 1. But keep in mind, your answer has to be between what and what? 90 and 0 degrees, or 0 and pi over 2 radians. Okay. There's a part B right there. There's a part B saying, hey, suppose your angle started here and fell in quadrant 2. Okay? Over here and falls in quadrant 2. What's your rule say for that? Pi minus what? Okay. So what you're going to do is write this in here. For quadrant 2, write pi minus your angle alpha, or if you would, also write 180 degrees minus alpha. Okay, because isn't pi radians the same as 180 degrees? Okay, and don't worry about this. Just get this down now, and I'll show you what the heck is going on here in a second. Okay? All right, what's it say for 3? Is it pi plus alpha? Alpha minus pi. No worries. Okay? Alpha minus pi. So in quadrant 3, a reference angle would be alpha minus pi, it says. Or your angle minus how many degrees, kids?
180.
Okay? What's it say for 4? 2 pi minus. But 2 pi radians is how many degrees? All right, kids. Highlight this here, here, here. Okay, let's see if we can't figure out what's going on. And I want to tell you what this is all about. We talk a lot about reference angle in the first quadrant because sometimes we talk an awful lot about real life problems. And in real life, a lot of the quantities that you deal with are what types of quantities. For instance, measure something in time. Are we measuring something in negative time ever? No. Okay? You run a certain distance. That distance you run, is that really going to be a negative distance? No, although you talk about that in science classes, maybe if I'm falling backwards or moving backwards, it would have a negative magnitude. Okay, or negative direction as well. All right? But typically, we like to talk about things in the first quadrant because they relate to real life problems where most quantities are positive. So what we talk about is say, well, what if an angle fell over here? What would a reference angle be like over here? Let's talk about what a reference angle even is. I'm going to start with this negative 125. Is that okay, kids? Okay. You don't need to draw this or write this down at all. All right? Here's what I want you to understand about reference angles, okay? I think some of you are looking at it like, what the heck do these numbers mean? Am I right now? You're like, what does this even mean? Let me show you what reference angle means, and I think that these formulas will make more sense to you, okay? Let me pull up my handy-dandy protractor. Oh, hang on. I've got the wrong one here. There it is. That's what I want. Okay. Do you guys know much about reference angles right now? Is that a fair question to ask? If I walked up and you say, what do you know about reference angles, what would you tell me? 4 quadrants. Okay, I'm okay with that. Would some of you look at me and say, sorry, Parson, nothing? That's okay. That's okay. Check this out. This is a pretty cool little tool right here. Okay, you ready for this? I'm going to do my best to put an XY coordinate plane up here. So give me a second, all right? How'd I do? Pretty good? All right. This is what reference angles are, kids. Okay, keep in mind, we want our angle for a reference angle always to be how many degrees? Be between how many degrees? 0 and 90. That's what it said in the rule. Or between 0 and pi over 2 radians. Do you agree with that? Okay, here's the deal. They're saying, suppose you had an angle right here that was 45 degrees. Which angle, or I'm sorry, which quadrant does that angle fall in? Well, quadrant 1, okay? So we're saying we can get a bunch of information about that angle right there if that angle is between 0 and 90 degrees and it falls in quadrant 1. Does 45 degrees fall in quadrant 1? Is it's measured between 0 and 90 degrees? It is, okay? Now let me show you something else. Suppose I go over here, and I'm going to use 135 as the example. All right, I have a question for you. Which quadrant is that angle's terminal side in? 2. Okay. Take a look at your notes. Is 135 degrees going to be a possible reference angle to even use, first of all? No, because the reference angle has to fall between what and what? 0 and 90. Let me show you something here, kids. Using your rule down there to get a reference angle for a 135 degree angle which falls in quadrant 2, what would you have to do to that 135 degrees to get a reference angle? 180 minus your angle, right? 180 minus your angle, because that's the rule, right? And we're talking degrees right now, so that's what we're going to be. What is 180 minus 135?
45.
Okay, so here's the deal. I'm going to draw this as best I can. 10, 20, 30, 40. I'm going to draw it as best I can. Don't yell at me, all right? What's this angle measure right here? Okay, that 45 degree angle would form that triangle right there in that quadrant, okay? Now we're saying, according to that rule, 45 degrees is a reference angle for 135 degrees based on rule. Because watch this right here. If I take this point out here in the unit circle and then draw my triangle this way. What do you notice about these two triangles? And we're talking about angles as a reference from our center point or where everything is equidistant from. Okay, we're always talking about this angle. So really, if I would follow this out here and then form a leg on the x-axis and then a vertical to get to that point, what angle is this still going to be right here, kids? 45 degrees. That's what they're coming up with. Okay, so that's what those rules are telling us. It's like saying, well, your triangle would be down here, but if we wanted to reference everything from the first quadrant, it would be like working with a 45 degree angle here. Okay, does that make sense? Better sense now when you see it that way? All right, so let's talk. Let's find some reference angles. Okay, I want to make this a bit easier for you. Am I correct in assuming that I think you guys work better in degrees than you do radians? Yeah. Okay. And am I also correct in assuming you probably like decimals more than you like fractions? Yeah. No problem. Okay. We're going to get along just fine this year then. All right. Here's what I want. Reference angles for the following. Okay. Here's what I think we need to do. $12 we need to come up with a reference angle for that. Ask yourself, first of all, which quadrant is it in? 1. Is that already between? Yes, it's already between 0 and 90. So what's a reference angle for 12 degrees? It's always nice when it's between. Okay? One thing I want you to do up here is this. Pi over 2 radians. Make a note over here. Pi over 2 radians is approximately 1.57 radians. Because if you take pi and divide it by 2, it's about 1.57. So if we start talking about radians and we're not sure if pi over 3 is between 0 and pi over 2, divide them out and see if it falls between 0 and 1.57. Does that make sense? Okay, let's chat. Oh no. We have to come up with a reference angle for negative 125 degrees. Gosh dang it.
That'd be quadrant 3.
How do you know that's quadrant 3?
Negative is below the line.
Okay, I'm going to draw some pictures up here. You don't necessarily need to draw this, but I'm going to do this. You guys agree that negative 90 would be right here?
Yep.
And then negative 90, how much more would I have to go?
Right there.
Okay, so this would be a negative 100 and, was it 125?
Yeah.
Okay, now I'm going to be honest with you. My brain does not work very well with circles if my number's not between 0 and 360. You guys agree with that?
Yeah.
So what I'm going to do is I'm going to find a coterminal angle to that. How can I find a coterminal to negative 125? Well, could I add to it right away? Add 360. Let's go from here, 360 around. So that negative 125 right here, what I might choose to do is add 360 to this here, kids. What's that equal? 200 and how much? 235 degrees? 235 degrees? Let me ask that question. Does 235 fit the window from 0 to 360 now?
Yeah.
Absolutely. This is the same as 235 degrees. Ooh. Still in which quadrant, Mr. Ben? We're still in quadrant 3. So let's find a reference angle that we could work with in the first quadrant. What's your rule for reference angle now from the third quadrant?
Minus 180.
Minus 180. 235 minus 180 would be
55.
55 degree angle, isn't it? Ah, gosh darn this pen. Now, could have done the same thing. I could have taken negative 125 and subtracted 180, which would have been negative 305, good. And then taken negative 305 and added what? 360 until I've hit that window from 0 to 90, okay? You gotta know which quadrants you're gonna fall in first before you can identify your reference angle. There's certain rules for certain quadrants, okay? You guys wanna do something to 468 first?
Minus 360.
Minus 360. So let's turn this into how many degrees first?
100 degrees.
This is the same as 108 degrees. It's coterminal to 108 degrees. All right, where's 108 degrees gonna fall, kiddos?
2.
Quadrant number 2. So what's your rule for quadrant 2?
180 minus
180 minus 108. So what would be a good reference angle to work from for 468 degrees in the first quadrant? Well, you know 108 is going to fall here 0 to 90. 108 is going to fall between 90 and 180. Rule for a reference angle then on that would be 180 minus your angle. What angle? 108. So what's this going to become? Yeah. Cool. Cool. Now we start talking radians, and this is where things get difficult. Any questions so far? Anybody? All right, here's what I would encourage you guys to do for the radians, okay? And maybe you guys can help me with this. For radians, this is the same as 0 degrees, 0 radians up to about 1.57 radians, which is pi over 2, okay? Anybody have a calculator handy for me? Take pi and divide it by 12 for me.
0.2617.
So 0.26 about?
Yep.
I have a question. Is that 0.26? Where's this angle going to fall then, 0.26, if this is 0 radians and this is 1.57-ish radians? It's going to fall right in here somewhere, isn't it? Isn't 0.26 going to be between 0 and 1.57, which is pi over 2 radians? So where does this fall initially?
Same.
Pi over 12. Is that value pi over 12 between 0 and 1.57?
Yeah.
So it's going to stay the same. Oh my goodness. This is where things get tricky. Negative 7 pi over 3. I'm going to do some drawing. Is that okay? Okay, how many radians are there in a circle? How many radians in your circle?
2.
2 pi, right? Okay. What are we dealing with? What value right now? Okay. I think anytime you have a negative angle, you should always make it what type of an angle first? Let's make it a positive angle first. So I would have to get a coterminal, we would have to add how much, kids? Add 2 pi. But that's the same as adding 2 pi over 1. We just got done talking not too long ago. If we're going to add 2 pi a whole revolution to make this a positive angle, we need to make sure that we have a common denominator. So we're going to have negative 7 pi over 3 that we're starting with. Plus what? 6 pi over 3. All agree? Okay, that only takes you where, kids? Going to have to do 2 rotations, aren't we? Yep, because this is only negative 1 pi over 3 right here. This is only negative 1 pi over 3 radians. So I'm going to have to add another 2 radians to that to first of all even make this positive. Where's that going to put you at, kids? No, we're going through this shuttle. Can I check with the kids here in a sec? Yep, I have prep next hour, and I'll put a feeler out. Okay. Negative pi over 3 here. Add how much here? So add another 6 pi over 3. You guys agree? Where's that put us? Okay, puts you at 5 pi over 3 radians. All agree? Okay. Where's that going to fall? That is a great question, isn't it? Radians are tricky, aren't they? How about I put some numbers up here to make this maybe help you a little bit? Is that okay? Okay, can you guys do me a favor? Can I see your sheet here, Hannah? Can you guys go to the very front page of your notes again? We had written some stuff up here about radians. Oh, I'm sorry.
Why did you add another 6 pi?
Because I said it would be really good if we could start this angle out as a positive angle first. Okay? When I add 2 pi radians right here, Emma, negative 7 pi plus 6 pi is still negative 1 pi over 3. That keeps us negative. So I say, all right, to make this a positive angle, I'm going to add a whole nother revolution to this again. Does that make sense?
Yeah.
Okay, great question. Guys, seriously, don't hesitate to ask questions. If you miss something, you're like, I don't know what the hell he's talking about, stop me. Give me a time to explain it better, okay? All right? This is tough stuff. This is tough stuff. But man, it's exciting. Okay, so I'm going to do something back on that first page. Are you on board with me now? All good? Okay, go back to that first page here. Let's make this kind of better for us or easier for us. Did you guys draw a circle on this the other day? Yesterday, I guess it was. Okay, what I would like you to do is this. We over here said this is like your 0 degree line, right? We said this is like your 90 degree mark up here, but we said this is also how many radians? Pi over 2. That pi over 2, I want you to put another number up there by this. Okay? This is also the same as 1.57. Put an R behind it so you know what that means. It's the same. Pi over 2 is about 1.57 radians. Okay? So over here we put what in radians? So this is 3.14 radians. Okay? What did we put down here? 3 pi over 2. So let's turn that into a decimal. Somebody do this. Take 3 times pi and divide it by 2 for me. Tell me you get about 4.71.
Yeah.
Okay, so this is about 4.71 radians. Even though we talk about this all in fractions. Remember what I asked you? I said, how many of you guys like decimals better than fractions? See what I'm doing here? We're turning all these goofy fractions into what? Decimals, because we think better that way. So this is about 4.71. radians. Hey, we get all the way around to 2 pi radians, one whole revolution. What is 2 times pi as a decimal approximately?
6.2.
Write these numbers down here. This will help you tremendously. Okay? We are looking for a reference angle to negative 7 pi over 3 radians. Okay? We said, well, we probably better not start out with a negative angle. We probably better make that a what? Positive. Okay, no problem. At this point right here, haven't we established for negative 7 pi over 3, haven't we established now that this is, oh, where did that go? Where did that sheet go? Haven't we established that this is 5 pi over 3 radians? Okay, keep that in mind. Somebody turn that to a decimal for me. 5 I'm sorry? 5.34?
5.24.
24? Thank you. Okay, quick question. Go back to that first page then. Man, if I could turn that into 5.24 radians and look at what we just converted, does that give you an idea of where that falls now?
In the first quadrant.
Which quadrant?
First one.
5.24. So it goes from 0 up to 1.57, right?
Oh,
And then to 4.71. Which one is it? Quadrant 4, right? Isn't 4.71 down here on the bottom? And 6.28 over here? So it falls in that fourth quadrant, right? Are you okay with that, Hannah?
Yeah.
Okay. So this is going to be quadrant number what? Okay. So listen to what I'm saying here. And this is kind of difficult. We came up with a coterminal angle to 7 pi over 3 of... Coterminal to that would be 5 pi over 3, right? Okay, this is in quadrant number what, kids? Okay, so to get a reference angle now, what does your rule say regarding radians to get a reference angle?
2 pi minus
2 pi minus your 5 pi over 3, in other words, right? Okay, if you start with radians, probably a good idea to end in what? Radians. So watch what we're going to do here. For this negative 7 pi over 3, we're now going to take 2 pi minus what?
5 pi.
Let's see. 2 pi is the same as 2 pi over 1. You want to subtract 5 pi over 3. Better make sure your denominators are both what then? 3. So 2 pi over 1 would be the same as what pi over 3? So for a reference angle, you're going to go 6 pi over 3. You guys agree that that's 2 pi, right? Minus our coterminal angle, which is the same as this of 5 pi over 3. What's 6 pi minus 5 pi up top? Pi over 3. Okay? Holy cow. Okay? Now, don't slam your arm in a car door yet. Don't do that yet. Okay? Because I want to show you something. And you're probably going to get kind of pissed about this. And you're like, really? You took us all the way through that and you didn't have to? Let me ask you this question first. Do you work better radians or degrees? Okay. Let me ask you a question. Do you know how to turn radians into degrees already? What if I would turn these radians all into degrees, work that way, and then put my answer back into... Was part B a mess?
Yeah.
Absolutely. Okay. Let's take a different approach on D, okay? This here is like a detour. You don't like detours, okay? This next one is like quickest way to get somewhere. All right? I'm going to put a frowny face by this one because that was kind of difficult. Okay? We're going to do a different approach right here. I'm going to kind of have a smiley face here. Okay? I don't like radians. And you should say the same thing. Say it with me. I don't like radians. No. In fact, you can say, I hate radians if you want. You can say it. I don't like, or you can hate them if you want, radians. Okay? Let's work in what? Help me, kids. I have 38. Watch this. I want you to turn 38 pi over 7 radians. I want you to find a reference angle for that. But we're going to do this differently. 38 over pi times 7. How about we turn this to degrees first? So what would you have to multiply by?
180 over pi.
Times 180 over pi. Now we're cooking with gas.
740 over 7. You haven't already
Gavin, you are my hero. Okay, what did you get?
6,840 over 7.
6,840 over what?
Which is
7.
977.14.
Okay, which is about how much?
977.14.
977.
Minus 7.
Okay, hang on 1 second. That 0.14. Somebody take 1 and divide it by 7 for me. Actually, forget that. Do this. We still have a goofy fraction here, don't we?
Yeah.
Okay. Well, we know there's how many degrees in a whole circle? 360. So if I subtracted 360 from this would be like subtracting 360 over 1. So do this. Well, let's just do this. We'll do it this way.
So you divide it by 7.
I'm going to tell you right now, 1/4. What the heck? We'll do it this way.
720.
So you subtract 360. Keep subtracting 360. You're going to subtract 720, right? And you're going to get 100 and
257.14.
okay.
So you're minus 17. Maybe I did that.
Which quadrant am I in? So how did I go from here to here, Gavin?
It's 257.
Let me back up. Do you understand the 977.14 first?
Gavin, it's 257.14.
Okay, 257 point, yeah, 257. Do you understand 257.14? Is that the question? So I'm at 900. I'm at 977 degrees. Does that fit one whole normal revolution of 0 to 360? So I subtract 360 once, and that still puts me over 360. So I subtract 360 twice. That's like subtracting 720. Now I'm working with an angle that is where, kids? Well, between 0 and what? 360, right? Okay. So which quadrant are you in?
3.
Quadrant number 3. And the rule is to take this angle minus what?
180.
Minus 100 and?
Would the answer still be in radians?
We could leave it in degrees if you want. Okay, we would call it 77.14 degrees. Okay. Now, there's a couple ways to do this here. That 77.14 degrees is 77 1/7 radians, which we could convert if we needed to. All right. If we could convert that, we could take that 77.14 times pi and divide it by what, kids? Now 180 again, because that's a rule. All right. Radians are not fun. I'm not going to lie to you on this, okay? Converting stuff is not fun, all right? But here's the situation. We're going to get more and more practice with this, okay? You're going to get some unit circle stuff. You're going to get a table of all this information too as we move forward, okay? So instead of having to come up with these numbers, there's going to be some information that's given to you to help you along the way. But the big idea is this. You need to understand a reference angle is in which quadrant every single time. Quadrant number 1, okay? The second thing you need to understand is there are different rules depending upon which quadrant your angle is in to begin with, okay? Now again, this is all like, wow, what do we need to know this for? Well, I'm going to tell you right now. If you don't know these rules moving forward, this is just going to be a nightmare. Okay, so what I'm getting at is this. Your notes are going to be very important. So because we just take notes over 5.1 doesn't mean when we start the next section, you still might need to refer back to these to see some things, okay? Does that make sense to you? Okay. What time does this end? 46? 43? 5 minutes. Okay. I'm gonna give you a quick quiz to take home with you this weekend. Okay? If you get it done, that would be awesome. I am going to tell you right now, however, Monday's going to be a work day for you. Okay? That makes sense? I would say kind of get started on the book page. My hope is to answer questions on stuff, but I am going to hand a quick quiz to you. Try to work on this over the weekend. Try to bring this to you by Monday, but understand also that Monday there's going to be some work time as well. Okay? It's tough. Trust me. If you're new to it, let me tell you. See this stuff every yeah, you'll get it too. You'll get it. Look, I'm going to walk you through this stuff. Don't panic, okay? excited. We have 22 kids in the Trig class. 22 kids in the Trig. That's awesome. I love it.
You guys, because he said, what do you want to do in life? And I said, die. On my own card.
Oh, tell me I have enough.
Yes.
Riley, I'm gonna have to make a copy of this quick. I'll send it to the library. You can pull it off in front of me. It's gonna say Trig, quick quiz 5.1, all right? You wanna head down there quick and I'll send that, all right?